All right, welcome back to the ELM test prep. I'm James S. and this is our continuing series on preparing you to take and pass your ELM test, which is your entrance requirement for many universities and colleges these days. Last time we talked about exponents and we didn't get to the fractional exponent due to lack of time or running out of time. I tend to wander off and not talk fast enough. So let's look at the fractional exponent. We talked about multiplying and adding exponents. Well, when we add or subtract, we need the same exponent. So adding or subtracting, we need the same exponent, and the only thing we will add is the coefficient. Plus and minus tend to separate terms, so you can think of a plus and minus as a separator if you want, and therefore that means that I'm not going to do anything with the exponents. The exponents will remain the same, and I will just add however many of those. In multiply and divide, that's not true. We're going to deal with the exponents, and we're either going to add the exponents for multiply or we're going to subtract the exponents if we're dividing. But let's talk about the fractional exponent. What if I don't have a whole number? And so we say, well, 9 to the 1/2. I'll start with a nice number so that we can deal with a little bit of specific here. What does that mean, 9 to the 1/2? I don't have any idea. I said, well, if I had 9 to the 1, I'd know that, or 9 squared, I would know that. But 9 to the 1/2, that's half of 1. So is half of 9, is that what I'm looking for? Well, no, to be blunt. Another way of thinking about this is 9 to the 1 divided by 2. 9 to the 1 divided by 2. The radical, and this is the exponent form, and this is the radical form of the same thing. So what I'm really looking for over here is I'm looking for the square root of 9, which is 3. Well, you might not have recognized that right off the top, but if you put it in this form, 9 to the 1 divided by 2, oh, okay, I'm looking for the square root of 9, which is 3. So sometimes they will ask you just to convert one to the other. They might give you this and say put it in exponent form. They might give you this and say put it in radical form. So that's the easiest way to look at this, is the number, that number divided by that. 9 to the 1 divided by 2. 9 to the 1 divided by 2. I take the 2 out there and I stick it on the index. Well, obviously, when we're talking square roots, now here again is one of those little efficiency things. I never put the 2 out there. If it's anything other than 2, I'll write it. If you don't see anything here, you have to know that that's a 2, which is real helpful because you knew that this was a 1, and this is exponential division, so 1 divided by 2 is 1/2, 9 to the 1/2. Well, let's look at another number. Let's say a to the 2/3. Well, again, I'm not sure what to do with that, but let's use our rule, and let's start with our radical symbol. And we have an a in here, a to the 2 divided by 3. Well, there we are. 2 divided by 3, 2 divided by 3. So the exponent form and the radical form have now solved themselves. So I can go either way. A2 divided by 3, A2 divided by 3. Notice the A remained the same. Sort of like a duck is a duck no matter which pond it sits in. All right. So, fractional exponents. 5 to the 3/5. Well, we start with our radical, and it's 5 times to the 3rd divided by 5. 3 divided by 5. When I say 3 divided by 5, that in essence explains the radical in itself. It's exponential division. And one of the other videos, we talked about that a little bit. So that's a fractional. So let's go back a little bit, backtrack a little bit, and let's go to division of exponents. A squared b3 over a b4. Well, we said when we multiply, we add exponents, and when we add or divide, when we divide, we subtract exponents. So division, we're going to subtract our exponents. If we were multiplying, I would add the exponents. Okay, well, how am I going to subtract them? Well, I'm looking A to A. I have one A down here and two A's up here. What I'm going to do is I'm going to subtract the smallest number of A's. I'm going to subtract 1 from this, and I'm going to subtract 1 from this. Well, I've done the same thing top and bottom, so I haven't damaged myself. Another way to think of this is I'm going to pull one of these A's out to the side. I have two A's up there, and I'm going to pull one out. Up here, I have three B's, and let's just say that I pull them out and separate them. And I have four B's down here. Okay, now we've gotten rid of the exponents, and we just put them in terms of the number of B's that we have and the number of A's. Well, I can say, well, A divided by A is just 1. That leaves me an A up there. I have 3 B's here and 4 down here, so crossing out B to B leaves me with a B on the bottom, so my end result would be the 1A over the remaining B, and I would have accomplished my task. Well, this is a little drawn out, so let's go back to the idea of subtracting their exponents. So I had A squared over A, and I'm going to give myself some room. B cubed over B to the 4. The idea here is I always want to take away the smaller one. I want to turn the smaller one to a 0. Well, this is a plus 1, so I'm going to subtract 1 from here, and I'm going to subtract 1 from here. Well, 1 take away 1 leaves me 0 A's. Anything to the 0 is just a 1. A to the 0 equals 1. 5 to the 0 equals 1. So it doesn't matter what value A is. If it's to the 0 power, it equals 1. You need to remember that. Okay, so I subtracted 1 top and bottom. Up here, I have fewer B's on top, so I'm going to subtract 3 there and subtract 3 here. 3 take away 3 is going to be 0. B to the 0 is just 1. So now I have 2 take away 1. I'm left with 1A up here. A times 1 is A. And I'm left with down here, 4 take away 3, I'm left with 1B there. And I have 1 times 1B, which is just B. And so there I have arrived at my answer again. All right, that wasn't too hard. So if I'm dividing exponents, some number with an exponent. Now remember that when I did this, I worked A's to A's, B's to B's. If I had a number up here, 3 and 9, I could say, well, this is really 3 times 3. I could then say that's 3 to the 2, and then I could do exponential division. Most times I won't have to do that because I can see the obvious reduction of the number. But if I were to have something like this, that would certainly be one way I could do it. I would subtract 1 from there and subtract 1 from there, so I'd have 3 to the 0, which is 1. And I'd take 1 away, and so I'd have 3 to the 1, which is just 3. So when I'm dividing numbers or letters, I have to have the same base if I'm going to work with them in terms of exponents. Numbers, I can work with them in terms of factors, and I can reduce them that way. So lots of times I don't use exponents. Well, let's see if I had a to the 3 over a to the minus 2. Well, this is the smaller one, but if I were to subtract 2 from this, I would just have -4. I wouldn't have 0. So the question is, I want to make the smaller one a 0. So this is -2. So what I'm going to do is add 2 to this. -2 plus 2 is a to the 0, and a to the 0 is 1. Then I added 2 down here. I'm going to add 2 up here. 3 plus 2 is 5, so I have a to the 5 over 1, which is just a to the 5. That was easy enough, and I see we've run out of time, and we'll have to address that again, possibly at a later time. Thank you for tuning in to my ELM prep series. I'm James S. Have a good day.